Good morning, ladies and gentlemen,
I'm Ray.
I'm Corey.
and I am Lucas.
Today, we stand before you to discuss one of the most pressing challenges of our time: how to solve global plastic pollution.
This issue is not just about cleaning up waste, it's about protecting our environment, our economy, and most importantly, our health.
So, firstly, they explore why this problem demands our immediate attention. In environmental impact, plastic pollution devastates ecosystems. It harms marine life, contaminates soil, and even contributes to climate change by releasing greenhouse gases during decomposition. Every year, millions of tons of plastic end up in our ocean, forming massive garbage patches and endangering countless species.
The financial burden is staggering. Government spends billions on cleanup efforts, while pollution damages industries like tourism and fishing. In many coastal areas, plastic waste has turned once thriving beaches into deserted wastelands.
Perhaps most alarming, microplastics have entered our food and water supplies. These tiny plastic particles are now being found in the human body, and while the long-term effects are still being studied, the potential health risks are deeply concerning. Clearly, this is a problem that affects us all. So, what's the solution? I believe the key lies in the transitioning to a circular plastic economy.
Imagine a pyramid. At the top of the pyramid is the concept of circular economy. This is an economy model that focuses on reusing, repairing, and recycling materials to minimize waste and reduce environmental harm.
Layer of the pyramid is the foundation of the concept reduce, reuse, recycle. These 3 Rs are not just slogans, they're actionable principles that guide how we manage plastic waste.
Finally, at the base of the pyramid is plastic innovation. This involves developing biodegradable plastics and other sustainable alternatives to our traditional plastics. With innovation, we can drastically reduce the impact of plastic pollution on our planet.
There are two specific approaches within the framework.
Bioplastics are made from renewable resources like cornstarch or plant oils. Unlike traditional plastics, they can degrade naturally in compost or in anaerobic digesters, making them far more sustainable.
In recyclable plastics, advancements in recycling technologies such as chemical recycling allows us to break down used plastics and recreate high-quality virgin plastic. This closes the loop in plastic production and reduces the need of fossil fuels.
To truly revolutionize our approach to plastic pollution, we need groundbreaking innovations. Here are four promising examples. Enhanced enzymes. Scientists have developed gene-edited enzymes like PETase and MHETase, which are significantly improving the efficiency of plastic degradation. These enzymes could transform recycling systems worldwide.
Second, synthetic microbes. By using CRISPR technology, researchers are engineering bacteria and fungi that can break down various plastics into valuable byproducts, such as biofuels or raw materials for manufacturing.
3. Modified yeast strains are tackling one of the most difficult challenges, multi-layer plastic packaging. These materials are typically non-recyclable, but super yeast can break them down layer by layer.
Symbiotic systems. Imagine entire microbial ecosystems designed to collaborate in degrading plastics waste. CRISPR-edited microbial consortia are being developed to work together, breaking down plastics faster and more efficiently.
In conclusion, addressing plastic pollution requires a collective effort. By embracing innovation, promoting sustainable practices, and enacting robust policies, we can transform plastic from a global threat into a valuable resource.
Let's create a future where we no longer see plastic waste polluting our oceans and cities, but instead we see it as a material reused, recycled, and reinvented for the betterment of humanity.
Thank you, ladies and gentlemen.